Welcome to this explainer. Today we're going to do something really cool. We're going to strip away the magic of software and look at the actual physical electrical reality happening right under the hood of your computer. We spend so much of our lives interacting with abstract software, clicking icons, watching videos, that it's incredibly easy to forget there's a tangible physical machine doing all the heavy lifting. So we're going to look past that screen to uncover the architecture of what we can call the 8-bit brain. So let's dive into a really fascinating question. Where does electricity actually become information? It's a profound thought when you stop and really consider it. We plug our machines into the wall, feeding them raw power, and somehow that power is transformed into documents, images, and the very voice you're hearing right now. By stepping away from the abstract screens we stare at all day and exploring the raw hardware, we're actually going to find the exact answer to that question. Okay, here is our roadmap for today as we perform an anatomical breakdown of an 8-bit computer system. First, demystifying the physical machine. Second, the system clock. Third, random access memory. Fourth, the arithmetic logic unit. And finally, electricity becomes digital data. Let's get into it. Section 1. Demystifying the physical machine. Now, what's really interesting here is the stark contrast between the abstract software interfaces we use effortlessly every day and the tangible physical components that make them possible. Software creates this perfect illusion, right? A seamless, user-friendly environment. But beneath that illusion is a massively complex architecture of wires, circuits, and logic gates. Our goal today is to totally shatter that illusion by visualizing its raw hardware architecture. To truly see this architecture in action, we need to look at how circuits are built practically, and we do that using a breadboard. Now, a breadboard is a physical board used for the practical, hands-on assembly of electrical circuits without needing to solder anything permanently. This brilliant educational approach is heavily influenced by the work of educator Ben Eater. And by building an 8-bit computer from scratch on a breadboard, we can quite literally see the physical pathways that electricity takes. Moving right along, Section 2, the system clock. Just like a living organism, the physical computer absolutely needs a heartbeat to function, and the system clock provides that driving rhythmic pulse. Now, to be clear, it isn't a clock that tells the time of day. Rather, it's an electronic oscillator that emits a constant, steady stream of electrical high and low signals. This pulse is the fundamental rhythm of the entire machine, and that pulse is absolutely critical. The system clock keeps everything in sync, regulates all those chaotic electrical signals, and serves as a fundamental building block of the machine's architecture. Without this continuous, steady heartbeat, the computer simply wouldn't be able to coordinate its actions. The clock ensures that every single component on that breadboard knows exactly when it's their turn to act. It's kind of like the conductor of a massive orchestra. All right, Section 3, Random Access Memory. You can think of random access memory, or RAM, functionally as the short for memory of our 8-bit brain. Just as you hold numbers in your head while doing mental math, the computer needs a dedicated physical space to temporarily hold the data it's actively working with. So, the crucial takeaway here is that RAM is not some mystical cloud. It's a very real physical component that stores physical data as electrical charges. It provides the system with immediate, high-speed access to that data, and it holds information specifically for the moments right before, during, and after processing. Basically, it's the active workspace where the computer organizes the electrical signals it needs right at this very second. Let's look at Section 4, the arithmetic logic unit. The arithmetic logic unit, commonly known as the ALU, is the fundamental building block where the actual math and logic operations physically take place. When you ask a computer to add two numbers or compare two values, that request eventually travels down to the ALU. This is the true heavy lifter of the 8-bit brain. And this is exactly why the arithmetic logic unit is identified as the fundamental building block of this machine. Honestly, it's quite mind-bending to realize that complex software mathematics actually boils down to physical electrical pathways crossing inside this specific unit. High and low voltages literally enter the ALU, route through a maze of logic gates on the breadboard, and physically produce a new set of voltages that represent the correct mathematical answer. It's just wild. Finally, Section 5, electricity becomes digital data. So here is how raw electricity flows through these physical components in 3 perfectly synchronized steps to create computation. Step 1, the clock beats, syncing the entire system. Step 2, The RAM provides the stored electrical data needed for the operation. And step 3, the ALU receives those signals and computes the physical math. They operate in this continuous, incredibly elegant dance of voltage. This precise sequence shows exactly how electrical signals are transformed into meaningful digital data. By tracing this path step by step on the breadboard, we can actually witness the exact, tangible moment where pure electrical voltage crosses the threshold to become meaningful information. It's no longer just raw power from a wall outlet. It has been fundamentally organized into a language. Ultimately, this anatomical breakdown completely demystifies the internal operations of a computer. It proves that the hardware architecture isn't magic, but fundamentally just beautifully organized electricity. By understanding the system clock, the RAM, and the ALU, we strip away the abstraction and see the 8-bit brain for what it truly is, an absolute masterpiece of physical logic. I'll leave you with this final, provocative thought. As you look at your software interface right now, completely immersed in the digital world, can you feel the millions of raw electrical pulses acting as the heartbeat of your own machine? Every pixel, every sound, every task is just wonderfully organized electricity flowing right there in the physical machine just beneath your fingertips. Thanks so much for joining me on this explainer.